Okay, we'll discuss distributed firewalling now. I think before we start going into what it is and how it works, I would like to present the problem statement on why do we need distributed firewalling and what is missing, okay? Again, just bear with me while I go through this example. Let's assume that you have a VNet with a workload. Obviously, a VNet will have hundreds of workloads, but I just put one for symbolic reasons for diagramming purposes. And then you have some VPCs in AWS, which have B, C, and D. And then all of these, as we all know now, we created, back in our discussion on network domains, we create 3 domains. The blue is dev, the red is prod, and the green is shared services. And what we do is we attach these spokes to the transits, and then we put each of those spokes in a network domain. All of this we have explained in previous lessons, okay? Again, all of this I'm trying to present why we need distributed firewalling. And then you might say, you know what, the green is the shared services, so everybody wants to talk to these workloads, so you will go and put a connection policy, if you remember, that is between shared services as well as prod and dev, so that prod and dev are able to communicate with shared services. The problem is that all of the network domain stuff that we are doing, and even on the connection policy, this is at a network domain level, meaning that, for instance, the instance A and D are within the same network domain. I am not able via network segmentation to say A is not allowed to communicate with D, because all what network segmentation is a VRF and a routing play. So if I have 50 instances here and another 50 instances in VPC4, with network domains, I am not able to be more granular and decide which workloads in the VNet that has the A can talk to which workloads in VPC4. Same problem is, even though I have put a connection policy between, for example, the VNet that has A and the VPC3, even because I put the connection policy with shared services. Again, if you have 50 workloads on this side and 50 workloads on the other side, I am not able to be more granular with connection policies. Okay, so this is partly the problem. Again, I'm showing a single instance. However, in reality, many instances will exist within the VPC. So somebody can go and say, well, we already talked about FireNet and did a lab on it, and it's a great, again, it's a possible solution to the problem. However, there are many things. Number one is many times the traffic can be blocked at layer 3 and layer 4. And the fact that I need to carry the traffic into the transit to take it to the firewall to be dropped might be a bit expensive. The other thing is that the firewall does not have visibility and thus cannot affect intra-VNet or intra-VPC traffic. I brought up the workload that is E. The firewall cannot see this traffic and thus is not able to enforce this traffic. Plus, it would not be logical, even if possible, to take that traffic through the spoke, to the transit, to take it to the firewall. I mean, it's a very long process, but reality is the traffic between A and E will be routed at the VNet router level, will not even arrive to my spoke gateway. And obviously, which means the firewall will not see it or know about it. Okay, so these are some of the problems that led us to think about the distributed firewalling and its need. Okay. So How does it work? Now that we've explained the problem, it works via two ways, or two things, basically. Number one is we leverage all of these four gateways as firewalls because they all have firewalling capabilities, right? So all of, let me just try to draw it in a better way. So all of these, instead of, in addition to being the fabric, in addition to being the data plane, they also become your firewalls. And your whole fabric becomes a cloud distributed firewall that is very near to your workloads and can block packets, again, within your VPC without having to take them to a central firewall, deal with things like data transfer and deal with the performance of the firewall and deal with other problems because we have distributed the architecture. Okay, and this is naturally where all the traffic was actually flowing, right? So we are just adding the functionality of having layer 3, layer 4 firewalling. And very soon, depending on when you will be watching the video, is the functionality to have IPS, IDS, basically intrusion detection system functionality also on all of these gateways. So we are pushing security into the fabric, which is, in my opinion, a very natural progression rather than having to put firewalls in central locations and going through a lot of complexity in order to send the traffic towards those firewalls, in addition to dealing with scaling and other issues of operating those firewalls. Okay, so your whole fabric becomes a distributed firewall, as well as intrusion detection system, as I mentioned. The other thing, which in my opinion is even very interesting, is this is one layer. This is, if you want to think about it, enforcement layer number one. But I mentioned the example between A and E. Well, we can orchestrate the CSP constructs, which means the enforcement layer number two is going to be the CSP, which is things like network security groups on Azure. And so, I mean, obviously, this will also come for other cloud service providers. So think about a firewall that you configure from a single pane of glass, and that firewall goes and looks where it needs to push the rules to which firewall. So think about it like this. Let me just try to. So you as a user, you deal with Copilot. And you say, I want these instances to talk to these. And the system is smart enough to go and push the rules to the relevant firewalls that need to get them. Not necessarily all of the rules have to go and hit all the firewalls. Would you just write your intent? Hey, I want, for instance, again, I'm giving an example. I want to have layer 3, layer 4 firewall. Maybe I want to allow this traffic, but I want to subject it to things like an IDS, and I want to do TLS decryption. And again, this is just as an example. And based on that, the gateways, the relevant gateways in the path will be programmed. Okay, so you have a distributed firewall that is configured and managed centrally, and that renders in a very, very intelligent manner across all of these enforcement points, in addition to leveraging the CSP's native constructs as enforcement points, so that we are able also to govern what is allowed within the scope of a single VNet. Okay, so this was the problem statement on distributed firewalling. So I think I alluded to this. So it enforces policy. Again, what is nice is you write policy, okay? And let me go back and maybe explain something a bit more. I would say it will make sense. So if I write policy in a single way. I'll show it to you now in Copilot. And I do not need to tell Copilot, hey, this needs to be enforced on the CSP, or this needs to be enforced on the gateway. I just write the policy. If I write a policy between A and B, for example, which are the workloads in the above diagram, that policy will be enforced maybe on the gateway of A and B, for example. However, if I write a policy between A and E, that policy will be enforced on the CSP network security groups. Okay, so I write a single policy, and the system is intelligent enough to understand, do these workloads live in the same VNet? If they do, then probably I cannot do anything on the gateway. Then I have to program the network security groups. All of this is done automatically for you. So now in terms of the components, right? How does it work? There is two important concepts. The number one is the smart group. Again, to use as of previously, this feature was called microsegmentation. Now we call it as distributed firewalling. So there are two components, one of smart groups, one is rules. Again, we talked about, we either have bespoke gateways as enforcement point or the network security groups for intra-VPC. So what is a smart group? Again, it's basically a group of like-minded resources, a group of resources that you need to give the same treatment, the same privilege, the same policy. Okay, so again, it could be something like I have 3 web servers, maybe that are part for the same application, just for scaling. And I can go and group these 3. Let me just draw this in a different color. So I can go and group these 3 in a group that I call web servers. Okay, and I can, for most of the time, in the CSP, I am going to rely on the CSP tag, okay, in order to place the resources in their respective groups. What does this mean? So I will go and say, hey, Copilot, when I'm define a smart group, okay? As I said, we'll call it web servers. And I'm going to tell it, hey, you know what? Go and fetch all resources that have the tag, for example, or tags, environment production, environment prod, and role is web servers, for example. And I just define this. What's nice is then the Copilot is going to go and fetch the CSPs on which resources actually match those 2 criteria. Obviously, it can be more complex. We can have more ands and or and logical operators, but the idea remains the same. The other benefit of why tagging is very powerful is the moment somebody uses infrastructure as code and spins up, go back and get this in red, and somebody goes and spins up a new resource, automatically, if it has the same tag that we were talking about, it will go and be part of the group. So we are not only grouping existing resources, we are also grouping any resource that comes onto the network that matches the same criteria. Okay, and I would say this is the most common way of putting resources in smart groups. You can obviously do CIDRs because many times, for example, you want to have a policy that allows your public address, because the other use case is we extend now this. Remember that we extend our data plane to on-prem with Aviatrix Edge. So generally on-prem, we are not going to be able to read the CSV tags. So we can resort to IP addresses as another identity mechanism. Again, CSV tags would be the most common, but we understand that there will be multiple use cases where IP addresses could fill the gap. So we have both of these possibilities. So this is an example of CSV tags. Like in AWS, you can go under tag and you say this is the environment part of staging, and the name is a shopping cart application. And then if you define the smart group based on these, then this instance, for example, will be part of that group. What we're doing here is just explaining a simple concept, really, which is about intra-rule or inter-rule. The idea is, for example, here we define two groups. One of them is Apache, one of them is Nginx. And you can notice that these groups span multiple VPCs and VNets. An intra-rule is dictating what traffic is allowed between the instances that belong to that group, right? So you are saying what is allowed inside this bubble or this group, versus an inter rule dictates what is allowed between these two groups. So one of them is about intra is about what is allowed inside, what is allowed, I can think of it like from Nginx to Nginx or from Apache to Apache. The inter rule is about the inter smart group communication. So the inter rule is defined among smart groups or between smart groups for dictating what kind of traffic is allowed among two or more smart groups. There, it's among all the instances that are part of that smart group. So one thing to note is that network segmentation and distributed firewalling can work together. The idea is you have multiple lines of businesses. For example, you have a line of business one and line of business two. What's very logical is that the groups can be inside those lines of business. So we're looking at line of business one, for example, which is the most of the diagram, right? We can see that within that line of business, in order to get more granular and separate, for example, the Apache and the Nginx workloads, this is where you will define the groups and map instances to those smart groups. And then this is where you can, for instance, define relationships between groups. This is where the inter rule versus the intra rule that we have alluded to. But I just wanted to clarify that you can have this functionality with other functionality. Network segmentation will help you separate the line of business one from completely seeing line of business two. However, the different groups of instances within line of business one might also want to be separated. Okay, so as per our like I mentioned, basically the network domains are, you can think about it like a higher level construct saying that VRFA cannot talk to VRFV, like dev and prod cannot communicate. And then you are within the scope of a line of business. This is where you will define your smart groups and define the relationship or the policies or the rules that govern the communication between the smart groups. It's very easy to create a smart group. You can, for instance, match tags where the tag is called type Apache, and you can see that resource selection 2 means that that there are 2 resources that are matched by this condition. You can have multiple conditions and make an AND or an OR expression. By default, the controller polls the CSP, meaning the cloud service providers, every 15 minutes to fetch the inventory. This is a timer that can be modified. And the co-pilot queries the controller every 1 hour. Again, this is another timer that can be modified. So what we're showing you again is that since we said 2 resources are being matched, these are the 2 resources that have the tag, which is type, and the value is Apache. Okay, if you want to manually trigger a fetching, you can always just click on refetch CSP resources, and this will take place. So after you define the smart group, you define, for example, one for Apache and one for Nginx, as we have been discussing. You can define the rules. And some of these rules can be, for example, the intra-ICMP Apache. This is the rule between Apache to Apache. So this is a rule that governs the relationship between the purple, the instances that are within the purple group. And we do the same for Nginx. We allow ICMP between those instances. And then between the 2 smart groups, this is where maybe we can also define the relationship. Whenever you configure a rule, you will need to, after you save it, you will need to, the rules over default are saved in a draft state. You will need to commit. And this commit is what will make the rule effective. Okay, if you click on discard, that will discard the changes. You only need the rule in one direction, meaning that these are firewall or stateful rules. Thus, you don't need the rule in the opposite direction. There is also the logic of an implicit deny. What do I mean by this? Assume that the logic is as follows. If I create a rule, for example, between Apache and Nginx, or even between Nginx and Nginx, and I only allow ICMP, that by default will automatically mean that only ICMP is allowed, because now there is an implicit deny that does not allow any other communication to actually take place. Okay, so if you allow the ICMP, it means HTTP is blocked, or it means any other, even SSH will be blocked between the two instances. Okay, so we're only allowing ICMP to actually take place. And this is, again, so any group that gets referenced in the rule, there is always an implicit deny that also, let me just try to explain what do I mean by this. So assume that you put a rule, you have, for example, smart groups. Again, let me give an example, A, B, and C. Again, I'm making it very simple. So you put a rule to say that from A, source A, source is A, destination is B, allow, I don't know, port 80. I'm giving an example. Okay, the moment you write this rule, okay, what's gonna happen is there is an, let me try to get this. There is an implicit rule that also gets inserted. This implicit rule says deny any traffic to reach A and B. Okay, the logic is that you have segmented A and B with the rules that you wanted to put. Thus, it's very logical that we have this implicit any because we don't want any other communication other than the one you allowed to be running. So this would mean that, for example, deny any means anything to get to A or B, which means, for instance, if you are to try an ICMP ping, okay, from let's say A to B, this will be allowed because this will hit the deny statement. If you are to allow to look at SSH, whatever you're looking at, this traffic will be affected. However, C, we have not currently placed C in any rule. And this means that C is still allowed to communicate with whoever it was allowed to communicate, meaning it's not going to be affected with this implicit deny. The implicit deny, the two resources mentioned here are the resources that are there in the group. Okay, any resource that is not, any group that is not mentioned in the rule will not be affected by the implicit deny. Okay, so because we wrote, if I, for example, let's just give another example. If I wrote the rule, again, A, B, and C, if I wrote the rule only from say source A and destination any, for example, ICMP protocol, okay, if this is what I did, B, only A, the implicit rule would say, deny any source to get to destination A. Again, here what I was writing AB, I meant destination AB. So B will be unaffected in this case, C will not be affected. The moment I go and write a rule for B, then B will also have an implicit rule. Okay, so the idea is that we are supposed to be writing the zero trust policy that allows the communication we need. So everything else will be blocked. Okay, so this is the implicit deny. Again, what's nice is whenever you write a rule, you don't have to always have it enforced. You can have it without enforcement. You can decide when to turn enforcement on. For instance, you're writing a deny rule and you're worried about enforcing it. You can turn, for example, logging on and make sure that this is what you want and then enforce the behavior. Logging will still log that there was a rule hit, but that rule is not actually going to enforce or drop or affect the traffic. Again, logging is another, I would say, very, very critical piece whereby it's very important that whenever you are writing those rules to see that there are rule hits. So you can always look at policy monitor to verify that the rules that you are writing are actually having a hit against them. Otherwise, your logic might not be 100% accurate. So in a nutshell, what we're doing is we're configuring the smart groups, we're configuring the distributed firewall rules, we're doing the commit, and what this is happening behind the scenes is the controller is deciding where to enforce the policy. Does it enforce it on the gateway or does it enforce it on the CSP constructs? Okay, So now we are going to move to the distributed firewalling lab.